Okay, so looking at transformations, this is a really important lesson because it will follow you into advanced functions when you go on to transform even more complex looking things. So this notation will still follow you through, okay? And it's also going to follow us through this whole course because then when we go looking at, for example, exponential functions, which is in Unit 4, we're going to use this same notation, transforming them. Unit 6, we're going to use the same transformation. Sorry, I'm getting a fraud call. We're getting the same transformations for sinusoidal functions, so those one that look like the waves, we're using the same notation. So this is kind of like a staple to grade 11. It's going to follow us all the way through. So first things first, we need to identify some letters here with our transformation notation. So with this, we've got an A in front here. We've got a K in the inner bracket, and then we've got X minus D plus C. And they all represent a different transformation or a different role that they play in moving it. F here is not a variable for transformation, so it doesn't have a role in changing the function. This is just like the placeholder for your function or for whatever function you choose to use. Whatever, there we go, function you are using. Which you'll see like when you flip the page, like we'll still use A, K, D, and C, but it's just gonna change in its formatting in terms of like whether we're using the absolute value function or the reciprocal function or the square root function, but we're still gonna have them in this order. So, okay, going through starting from left to right. So we're gonna start with A, and we said, if A is greater than 1, or if it's just a whole number, bless you, then there is a vertical stretch, which you have learned in grade 10. You did learn about stretches and compressions of parabolas, right? And that was always associated with like the number in front. And then the same thing, if A is gonna be between 0 and 1, which is what that notation means. So if you're seeing like a fraction or a decimal that's gonna be less than 1, then it's a vertical compression. Right, and you can imagine like this is like a vertical stretch, so it's getting like skinnier versus like this is a vertical compression, it's gonna get wider, right? If A is negative, then we're gonna say it's a reflection in the x-axis. So like with parabolas, that's when we saw it going from like smiling to frowning when it opened downwards, right? When we look at K, we are just reversing these rules. And this is a new transformation that you haven't done before. So this is new. So now we say if K is greater than 1 or a whole number, now we're going to say that that's a horizontal compression. So before we associated whole numbers with stretches, now we're saying they're compressions, right? And same thing with the reverse. If K is going to be between 0 and 1, or a fraction or a decimal that you see, that's going to be considered a horizontal stretch. And you can think of it as the opposite of like how we said this is a vertical stretch if I stretch this way, and that's going to make it skinny. The same thing. A vertical compression is also going to compress a function and make it like that very like stretched notation. So it's like the same thing. Same thing if I like vertically compress something to make it wider. It's the exact same thing if I were to do a horizontal stretch and pull it apart. So the same kind of transformation's happening. And then same thing. If K is negative, then that's just going to be a reflection in your other axis, so the y-axis. I always think if you can memorize the rules for A, then you know just to flip them for K. So if you can memorize like whole numbers a stretch and decimals a compression, then you know for K, I just have to flip those, right? Okay, moving into D and C. So if you have a D value that is positive, meaning your bracket will look like X minus D, right? Because we consider it as a placeholder. Remember in like vertex form when it's like X minus 3 squared plus 1 means the vertex is at 3, 1, not negative 3, 1. We don't change the sign. That just means you're translating to the right that many units. Versus if you've got a D value that's negative and you've got a bracket that looks like X plus D, so the opposite sign, Then you're translating to the left. And then last but not least, C, which you have seen this one before. This was like, for example, shifting parabolas up and down. If C is positive, then like no funny business. Positive just means you're going upwards. And then you guessed it, negative means you're going downwards. So that one is pretty straightforward. No flipping of rules. So this is like your total guide to transformations. This will be your reference for everything and will help you kind of through this lesson, kind of judge like which way are you going. So even if I just gave you this general function, I said just state the transformations that have been applied to this function f at x. The fact that it's an f just means it's some function. I don't know if it's a parabola. I don't know if it's a square root function. I don't know what type of function it is, but this function has undergone transformations, and I'm just going to refer to A, K, D, and C's rules to describe what's happened to it. So, okay, starting with, I would label what is your A, what is your K, what's your D, and what's your C, which it looks like in front, I've got my A is equal to -2. My K is equal to 3. My D, which is that going to be a -1 or +1? +1. And then lastly, which I'll do purple, I'll do a different color, my C, which is 6. So, okay, I've identified all of them. Everything's in the place that it needs to be. Now I'm just going to go left to right and describe my transformation. So if I look at A, for example, I can see that it's -2. So I think, okay, for A, it is greater than 1. It's a whole number, so that's true. So that's going to be a vertical stretch. So I can write that. Vertical stretch. And then we say by a factor of 2. But it's also negative. So the negative is also a transformation. And we said, okay, if A is negative, then I'm reflecting. So I can also say there's a reflection. Reflection in the x-axis. So, okay, A is done. I'm moving on to K, which I'm going to do the same thing. I'm going to analyze the rules for K and say, okay, K is a whole number. So according to these rules, is it a stretch or is it a compression horizontally? Yeah, Maddie? It's a compression. So I'm just going to say it's a horizontal compression. Now, this one, we describe it by a factor of, but instead of saying what your number is, and I hate this rule. In high school, I absolutely hated it, and I never did it, but we are supposed to flip it when we describe it. So instead of saying by a factor of 3, we would say by a factor of 1/3. Why we flip it, I feel like is redundant because you're saying it's a compression, but that's the whole point of like compressions. We always identify as like these fractions and decimals. So technically and like mathematically, they want us to write it like this. So you're just flipping it when you describe it. When you go to like insert it into an equation, or like you're gonna see when you use it to like transform points, you're just using 3. So you only flip it when you're just describing it to somebody, yeah? Only K. That's why I'm like, this new transformation comes in grade 11 and is like, I'm gonna be complicated. I'm just gonna shake it up. It's okay. I've got that. And that's it. It's not negative, so I don't have another reflection. It's only that.
Will that be marked
What?
on the test? Will we have a question like this?
This is not on your test.
I mean, what?
Or for that test? What, like if you say just by like a factor of 3? Yeah, like a 0.5. A tiny little mark, I'll just correct it because it's like proper. And I know Mr. Mosley in grade 12, he's like to the book. So he's gonna hold you to the standard. So that's why I'm preparing you for him, right? D, we said is +1, or we've got this x minus 1 in our bracket, which we said, okay, if I've got x minus a value or our D value is positive, then I'm moving to the right. So this is a shift 1 unit right. And then lastly, C, which that's on the outside, that's 6, which we said if C is positive, then I'm going upwards. So this is just a shift 6 units upward. And voila, you've described every transformation that this function has gone through. And that's it. The one below it is the reverse. So now it's told you the transformations of what has happened to it, and you have to decipher, okay, which transformation corresponds to A, or which one of these corresponds to my C value or my D value. And then you're gonna make a general equation using that. So we're still gonna follow this format, right? The same format at the top of your page. We're following that. So, okay, I'm reading this, and I'm just gonna, again, use my colors. I'll use the same colors as the example above, where I use like blue for A, pink for K, green for D, and purple for C. So I'm gonna read this, and I'm gonna see, okay, it's being vertically compressed by a factor of 3, which, okay, vertical compressions, that deals with A. So I'm gonna highlight that in blue, because that's an A value. You could even write A underneath it if you want. Reflected in the x-axis, which I would look and be like, okay, reflections in the x-axis, that's still attached to my A value. So this is also part of A. And then I'm shifting 4 units right. What does that have to correspond to? Yeah? D. So, okay, I'll highlight in green. That's my D value, shifting left and right. And then 1 unit down. What letter is that? C. Thank you. That's it. So I don't have anything relative to K. So in this case, when I go to write these values, my A value, it's saying I'm being vertically compressed by a factor of 3. It's my A value, so I don't have to do any flipping. That's only K. So I know it's going to be 1/3 since it's being compressed. Compression means it's a fraction. So even though it wrote a whole number there, 3, the fact that it's telling me it's a compression, I should know I need to flip this into a fraction. And then lastly, the fact that it's reflected means this is also -1/3, since it's going to be reflecting in X. So that's done. K, if I don't have a value for either A or K, so like let's say they didn't give us any description, it is automatically just 1. Right? You can't have a compression of 0 or a stretch of 0. Same thing like when we talked about in parabolas last year. They said for your function, like if you're in vertex form, and you don't have to write this, but this is just to me show you. If I had a 0 here for A, what would happen to like the whole equation? Yeah.
I was just wondering, what form is this?
This is general notation form. So like the thing at the top of your page, we're gonna follow that because we don't know what function this is. Right? So this is just like some function has undergone these. But if I have a 0 in front, this is saying like 0 times this whole expression. What happens to it? Disappears. There is nothing, right? So we can't have a vertical stretch of 0 or a horizontal compression of 0. So if you don't have anything for A or for K, it's automatically just 1. Yeah? Like in the equation, you don't have to write it, which we're gonna see. But I'm just stating there for you, it's 1. For D, it's shifting right. So is it gonna be +4 or -4? +4. And then lastly, C, I'm shifting down. So is C gonna be +1 or -1? I heard -1, exactly. Now, when it comes to actually putting this in the notation, right, I'm following just what's up here. So I'm following the same format. So I'm going to do up here. F of X is equal to, I start with my A value, so I know, okay, that goes in front, so -1/3. I'm going to use my F as a placeholder since I don't know what function I'm using this for. So I'm going to use F. Then you'll use your square bracket, and that's where you're going to put all the inside stuff, like K and the X minus D value. So like Maddie said, because K is 1, I don't need to write a 1 here. It's kind of redundant. It's like we don't say like 1X, we just say X. So I don't have to put anything there. And then I'm going to do X minus 4, square bracket, and then -1. And you're done. So then if I told you that that was a parabola, for example, then you could plug in those values specifically where you're going to see x squared, right? Or if it's a square root, you'll see the formatting. So this is just like a general function. Am I okay to flip? Yeah, or Lorenzo, is that a question?
If you don't do square brackets, you for that.
Mhm.
I assume that's 0.5?
What, like if you did like this, like 2 and then like x minus 4 if there's a value?
Yeah.
Oh no, I'm not a hateful person. I don't care.
When we do the domain and range, will we get marked up if we do regular brackets?
What, instead of like the little
Yeah.
squigglies? I would say try the squigglies. It's notation, but like again, like I'm human. I know they're ugly, they're hard to draw. Just try your best. And again, I'm just showing you proper notation. If you were to do a second pair of like round brackets, I'm not picky. I just care about if like the content's right. So no, I wouldn't take a 0.5 off for that. Don't worry. So this is the transformed parent notation. So this is what happens when you replace f as like your little placeholder for a function with the actual function. This is where a, k, d, and c are actually gonna go in this notation. So like with our absolute value one, where we've got like our 2 straight brackets, we're just keeping a and c on the outside, and then you'll notice k and d get to be on the inside of those square brackets. And you'll notice a pattern. Same thing with square root. A and C get to be on the outside of the square root, whereas K and D are underneath the square root. So they're again inside the function. And then with the reciprocal, I see a lot of people also write it as like, and it's equivalent. You could also write it as like A and then times 1 over K x minus D plus C. I personally like, I don't like this because then it gets confusing as like, what is A multiplying to, and fractions just confuse people. So A is on top, K and D get to be in the denominator, and then C is just not attached to the fraction. So that's your shift up and down. So this is what you could use if I specifically said like, can you do a transformed square root function? Or can you do a transformed absolute value function? That is the specific notation you'd be using instead of using an F, right? Since now we know what the function is. So for example, I want the square root function, I want the transformed version after it has undergone these specific transformations. So again, I'm going through and I need to figure out what's associated with A, what's associated with K, D, and C. So like, let's read this out. Vertically compressed by a factor of 3, what does that have to deal with? Or what letter is that associated with? A vertical compression. A. This is A. It's okay. This bit's A. Reflected in the y-axis. Is that A or K? That's K. Ooh, so that's going to be related to K. And then I've got a shift 1 unit left, which is that going to be D or C? D, yeah. And then 5 units, it says upward. So that's my remaining one. So that's going to be my C, which I'll even continue it here. So, okay, perfect. I've got my A, my K, my D, my C, and I'm going to translate these now into values. So, okay, I've got A is going to be equal to, it tells me a vertical compression by a factor of 3. So I need to state that this is going to be 1 over 3. Again, the compression is like the hint, nudge, nudge of like this is a fraction. We don't think whole numbers are compressions, right? So we have to change it. But it's positive. It doesn't tell me I'm reflecting, so that's done. K, it doesn't tell me a specific value that it's being like stretched or compressed by. It only tells me it's being reflected. So what do you think K would be in this case? Yeah? -1. Thank you, Adam. Right? Just -1. And then D, we've got a shift left. So we have to think, is that positive or negative for my D value? If I'm going left. Is that going to produce a negative D or positive D?
Positive.
Oh, I heard different. It's going to be negative. So this is a -1. And then lastly, your C, your shift up or down. We said it's upwards, so this is just going to be +5. It's like, okay, I've got all my values now. I'm going to plug them into the function. If you want to start with just the general form, which I'll do up here, f of x is equal to a, bless you, square root k x minus d, and then plus c on the outside. Then you're just going to plop your values into the expression. So this is now just going to be f of x is equal to, my a value goes in front, so 1 over 3, and then square root I don't have a value, so I'm just gonna put the negative sign. I don't have to put -1. And then I have x plus 1, since I'm going to the left, so I'm following that same notation, and then plus 5 on the end. Was this okay how I just inserted it into the equation? Yeah? Can we put it away? Thank you. Is this okay? Okay, then can I task you with using those same values for A, K, D, and C, can you put it into a reciprocal function? So using the transformed reciprocal one at the bottom, can you plug those same values in and like what would it look like? How would that equation look? Do we know? Well, you've got the formatting up here, right? You've got the reciprocal function format, so it's telling you where A, K, D, and C go. So just using those same values, can you just match it to that format? Oh. Okay, noted. I'll bring more. We've got like a whole stack of them in that box. Yes, Abby. You can put a fraction in a fraction. Oh, I'm always trapped. I forget that I can't go that way.
Oh, right. Honestly, this is a lot of stuff to mess your test. I have to memorize these equations and memorize these. But this is yes.
We don't need to solve, we're just putting in function notation, which looks great, perfect, which, okay, I'm gonna try again. I am not limber. Oh, there we go. I can't even touch my toes. Did you know that? I think my arms are disproportionate to my body. I think they're just too small. Okay, you guys got this perfectly, which makes me so proud, which if you're just following that same notation up top, which I'm just writing the general form of A all over, and then we've got K, X minus D plus C. You're just doing the same thing where you're putting your values in, which you are allowed to have a fraction and a fraction, that's fine. So people said, okay, 1/3 on top, and then they did negative X plus 1 on the bottom, and then plus 5, right? So that is normal, that's fine. Perfect, okay, so you will notice, like how I said, A and C always get to be on the outside, whereas K and D always have to be on the inside of the function. So if you've got some colors here, you can say everything on the outside. Right, so A and C is going to impact your Y values, which I'm gonna then highlight in pink here. Right, so A and C, the vertical compressions and stretches, as well as the shifts up and down, those are gonna change your Y coordinates when you're moving a function, right? Because think about it, you're stretching or compressing a function, so that'll move your Y values up or down, versus also shifting up and down, also change your values for Y. Whereas you can assume everything on the inside, right? So your K and your D stuff, that's gonna impact your X value. So that's gonna shift your X coordinates around. Right, so whether you're shifting left and right, or whether now you're being squished, so now your X coordinates are gonna get closer together, or they're gonna get stretched and pulled farther apart, you will know that those are gonna impact your values. So we have what's called a mapping rule. And mapping rule is your BFF. It's gonna help you transform these really ugly functions through this formula, essentially. So for any coordinate point that's on your original function, so this is like an original point on f at x. Any point you got, you're gonna send it through the mapping rule, which using your values of transformations, you're gonna say x over k plus d So you've got your two values that are impacting x, and then you've got a comma. So that's just gonna be your new x coordinate. And then you're gonna have a times y plus c. And that's gonna form your new y coordinate. So you can even write, this is new x coordinate. And this whole bit is gonna be your, I hated that, there we go, new y coordinate. And that's gonna tell you basically where to plot that point on this transformed graph. So if you can at least do like 3 points, you can have enough information to see a curve of your new function, which we're gonna do together. It's okay, am I good to flip? Or do we have any questions or anything we wanna clarify before moving on? Yeah? Yeah, just check your phone. Okay, so we're gonna get into it. So for example, it's telling us that these points, 1, 5 and -3, 6 are on a function. And now we're gonna use the mapping rule to find where do those transformed points map to, essentially, like where are they going on this new transform function? So first things first, I need to figure out like what my A, K, D, and C are to build my mapping rule. So I gotta find what my transformations are. So, okay, looking at just, again, general notation, you're thinking about the whole, and I'll even write it here as like a reference. F at x equals A, F, K, x minus D plus C. So that's what I'm trying to like reference to. Do I have an A value? Or do I have anything like in front? Do I have anything in front of F, even to be more specific? Yes, no, maybe so. No, right? I don't have anything in front of F. There's no like coefficient here. So it is just automatically 1, okay? It's nothing there. Same thing. Do I have a K value? Do I have like this second set of brackets with a coefficient in front? No, so K is also 1. Then I have to think about D. What is my D value gonna be? Because I've got x plus 2, so yeah. -2, perfect, thank you. And then C, lastly, our thing on the end. What do we think? Just our constant, right at the end. -3, totally, yes, -3. You got it, right? So, okay, now I've got my values, I can build my mapping rule. So now I know that my mapping rule, or the formula that's gonna transform all of my points, I'll write the general form first, just to like re-jog our memory, where we said x over k plus d, ay plus c. So now I'm just gonna take my values that I determined from this equation and plug them in. So this is like x over 1 minus 2, and then my a value is like saying 1 times y minus 3, which then you can obviously like alter this. If you want to keep it like this, that's fine, but you know anything over 1 is just itself. So this is really like x minus 2, y minus 3. All right, so that's me simplifying it. If you don't want to do the simplification stuff, you can just leave it like that. That's totally fine. All right, and now I'm just going to send my points through the mapping rule. So I'm saying my first point, 1, 5. This is your x and your y. So those are going to now replace x and y in the mapping rule. So now this is just going to be 1 minus 2 and 5 minus 3, which that just simplifies to 1 minus 2 is -1, and then 5 minus 3 is 2. So that is now its new point after being transformed. And I'm just repeating. So -3 and -6, same thing. The only thing that's changing is I'm changing the placement of like x and y. So now this is going to be -3 minus 2 and -6 minus 3, which what is that going to simplify to? What's my new coordinate point going to be? What do you think? -5 and -9. That's your new point. Done. Perfect. That was a nice little easy one. I realize I have 2 A's here. Okay, B. So the second one, I see, okay, it's got more happening. I've got an A value, I've got a K value, but I want you to pay so close attention to that inner brackets because we need two sets of brackets. K has to be by itself. So I need to factor that inner bracket. Factor, and I want you to put like 60 exclamation marks because I can't tell you how many people still don't do it. Right? You have to do it because that'll totally change your mapping rule and what your function's gonna look like when you actually go to plot those points. So this is really gonna be 1/4f. And then what can I take out of -3x plus 9? What do they both have in common? Yeah, -3. And then I'm gonna be left with x minus 3. Voila, now we have a k value by itself. So I can say, okay, my a value now I know is the front number, whatever's in front of the f. So that's gonna be my 1/4. My k value is -3. But now my d value before, if I didn't factor it, I would have been like, oh, +9, so that's -9. But it's not. Now that we've factored out the k, we can see, oh, my d value is actually gonna be +3. So way different than if we hadn't factored. And then c value is 2. Okay, rewinding.
It seems like it's an inverse of the symbol. I assume that's just coincidence, but
For which one?
for K, the only difference is instead of it being a -3x, you would have reversed it. All he did was.
I just factored out a -3 out of the inner brackets. That's it.
Oh, wait, so D would have just, all it did was reverse it.
Yeah, because I just did 9 divided by -3. No, you got it. No worries. Is this clear how I got these values? Yeah, D's okay? All I did was factor out -3. So it's like I did -3x divided by -3, just leaves me with x, and same thing, 9 divided by -3 is just -3. It's okay, I've got it. Now that you've got the points, what's your mapping rule gonna look like? Mapping rule. If I start with just my x values, x over k plus d. So this is gonna be x over what? What's my k value? And then plus d, so 3. Perfect. And then my y values, I've got a times y. So this is going to be 1/4y. And then plus c. There's your mapping rule. Do you want to try putting those 2 points through the mapping rule and then we take it up? Okay, you tried. So same thing like we did here. We're going to do the same thing where you're going to take 1, 5 and -3, -6. So it's the same points still, the same 2 points. But now you're going to put them through that mapping rule, and you're going to tell me what you get. Do, if it's recording, same thing. So I've got 1, 5 that I'm sending through the mapping rule, and I'm going to replace it where we got 1/3 plus 3, and 1/4 times 5 plus 2. Which, okay, that's going to be a little ugly. So we've got 1/3 plus 3. Which you could try and do like a common denominator here of like this is over 1, so I have to times this by 3. And now this is -1 plus 9, which is going to give us 8/3. And then same thing, we've got 5/4. If you want to do this rough work here, or you can send it through a calculator. Like I'm not checking your mental math in here. So 5/4 plus 2, and then common denominator, I got to times this by 2. So now this is like 4. So now I've got 5 plus 2 times 4, which is 8. And 5 plus 8, that's going to be 13. So 13/4 is your final answer, which as decimals, those are like gross numbers. 8/3 is 2.6. So Edward, it was 2.6. And 13 divided by 4 was 3.25. Yep. No, not necessarily. The whole fraction is a negative. So even you still would have gone like the same answer. Yeah, it's fine. Okay, because this is still like negative 0.33333 plus 3, so you should end up with a positive number. Yeah. So this negative, even though it's in the bottom, right? Even though it's in the bottom, it's like you're saying negative 1/3, which is negative 0.333 onwards, right? If you're adding a 3 to that, you should end up with a positive number. So you're not going to end up with like negative 1 or 1 minus 9. So you don't have to times by negative 3. The negative sign just applies to the whole fraction. So I always just boot it up to the numerator, right? Or this is where you can like do your calculator, right? And you can show those steps there. Same thing if I do negative 3, negative 6, I'm doing the same thing where I'm replacing the numerator. So negative 3 divided by negative 3 plus 3. And then 1/4 times negative 6 plus 2. Which, okay, negative 3 divided by negative 3, that's just something divided by itself. So that's just 1. And 1 plus 3 is 4. And then I've got negative 6/2. Or negative 6/4 plus 2, I should say. And if I go to do a common denominator and times this by 4, that's going to give me like negative 6 plus 8. Negative 6 plus 8 all over 4, which is just going to give me 2/4, which is a half. So we know, okay, this is a half, which again, I encourage you. Get a good calculator that can do the fractions and the crazy operations. This will definitely save you when it comes to doing, for example, when you've got an A, a K, a D, and a C, and maybe they're all fractions. Like maybe they're super ugly. So that's why don't always count on mental math. It's good to have, but always like double and triple check with a calculator, right?
Get a TI-84, then you can also play Dude.
And then this is oh really? Because this is a natural VPAM. I think you can do like a coin toss on it. That's like the most game it gets. Okay.
The TI-84 is also a graphing calculator.
Those are mega expensive.
Yeah.
So you'll see, we're almost done. We're literally at the end. So I'm gonna do this sketching one with you, and then you can do this sketching one by yourself. So we're gonna work up for it, okay? So for example, now when it comes to sketching them and actually visually seeing our transformations come to life, it says use the mapping rule to sketch both the parent function, which we can see is the absolute value of x, that's our V-shaped graph, and its transformed graph, which I've got right here on the same axes. So, okay, I'm gonna do my parent function in blue, or no, actually, I'll do my parent function in pink. So I'm gonna say f of x is equal to absolute value of x. And how do we graph this guy? Do we remember how to graph the absolute value of x? It's kind of like a parabola, but it's got the straight lines. It's a V for absolute value, right? That's how I remember it. So exactly, it's like you're starting here, and then you're just going up 1 over 1, up 1 over 1 for infinity, and same thing on the other side. You're going up 1 over 1 in the other direction. So you're just making a straight V. That's the original. I think that's like the easiest of the parent functions to graph, other than like a line. Right, so okay, that's our original. Now I need to go looking at the g of x, that's our transformed function. And I gotta state, like, what's my a, what's my k, what's my d, what's my c? So okay, first off, what is my a value? 2, perfect. What's my k value? 1. My d value? 3. And my c value? Awesome, -4. Perfect. I'm now gonna put these into the mapping rule. So, okay, here's my mapping rule, which I'll do the general notation just for you to see it again and get familiar. So, okay, it's x over k plus d ay plus c, which then if I go ahead and put my points in, what's my mapping rule gonna look like? You can just say it. I've got x over what? X over 1, yeah. And then what's next? Plus 3. Okay, my x is done, so comma, and then I'm moving on to my y stuff. What's that gonna look like? 2y minus 4. Thank you, Izzy. Perfect. Which then if you want to change this to just x plus 3, since x divided by 1 will always just give you whatever x is. You can. I think it makes it look a little easier. Okay, now the last step, which I'm going to actually make this a little smaller because I got a little greedy on space, is now you're going to take some points from your original function and you're going to send it through the mapping rule. So I say, as a guideline, 3 points is enough for you to kind of like get a shape. So we're going to pick 3 points, or 3 of those anchor points from here, which I personally like these first 3. I think like that little start of the V is more than enough for us to then see like what is that going to look like. So this point is 0, 0. Then we've got 1, 1, and negative 1, 1. So those are going to be my 3 points I'm sending through the mapping rule. So okay, I'll do like left to right first. So okay, let's do negative 1, 1. So okay, I'm going to send negative 1, 1 through the mapping rule. That's going to leave me with negative 1 plus 3, and then 2 times 1 minus 4. Which, okay, negative 1 plus 3, that's going to just simplify to 2. And then 2 times 1 is 2, minus 4, that's negative 2. So that's going to be our new point. And I'm just going to repeat. So now 0, 0, that's going to be an easy point. I'm just replacing 0 plus 3 and 2 times 0 minus 4. Which that's just going to leave me with, it looks like 3 and negative 4. And then my last point, 1, 1. Same thing, I'm sending it through the mapping rule. 2 times 1 minus 4. The x value is going to be different, so 1 plus 3 is 4. But it's going to be the same x value as above, since like we have that like mirroring going on. So 2 minus 4 is again negative 2. Okay, I've got my 3 points. I'm going to go ahead and just plot them. So okay, 2 and negative 2, that's going to be 2, negative 2. All the way down here. Then I'm at 3, negative 4. And then I'm back at 4, negative 2. And would you look at that? There's your function. Oop, here we go. I gotta make this a little wider. The autocorrect never gets it right on the first try. There we go, close enough. Okay. Which this is more than enough to connect. If you want to do more points for like actual accuracy, you can do as many points as you like, but I'm only ever going to ask you for like 3, maybe 4 max, depending on what the function is, if you need more points to see it. Yeah, Chloe?
How come like the transform functions like in like the negative if like the absolute value is always not positive?
Because we shifted it down. So when you transform an absolute value function, right, you can then go into the negatives because you're moving where your start point is. For just the pink one, you'll see you'll never get a negative output, right? But once we move it down, right, or we shift it left and right, you could potentially get a negative output because your outside stuff will just be more negative than the inside stuff. Yeah.
Is it because like everything inside the absolute value bar is going to be positive, but it's because we have C, which is negative?
Exactly. You've got stuff on the outside that's a negative. So because we're like shifting 4 down, that's why I'm going into the negatives now. So anything in here will be positive. Anything in here will be positive. But if this outside value is going to be negative, or like your A value is negative, that's going to turn everything negative. So that's going to be your new function, which I'll just even plot here. 3, negative 4, and then 4, negative 2. And that's it. You're going to do those same steps every single time. So for the last example, which I would aim to get done, I gave you a square root function. I told you the transformations that have happened to it. So I want you to now translate those to A, K, D, and C, create your mapping rule, send it through the mapping rule, and tell me what is your function looking like. Would it help if we did the parent function together?
Yeah.
Yeah? Okay, we'll do the parent function. Lorenzo, you need your phone? Okay, perfect. So, okay, the parent function for the square root function, I'll help you with. I'll do that in pink. So f of x equals the square root. And you'll see as the semester goes on, especially as like you study and continue like for the exam, you'll just memorize this function by its anchor points, which I would also say is super helpful. So like instead of doing like a table of values and being like, okay, if I plug in 1, it's this. If I plug in 2, it's this. you can memorize the anchor points as like your square rootable values. So your anchor points for this function are 0, 0, 1, 1, 4, 2, 3, 9, and I think that's like all you can fit. I don't think you can go up to like 4, 16. Or sorry, this should be the flip. 9, 3. Right, but it's the idea that it's like I took like all my square rootable values and then I just like plugged them into like square root x. So you see it's gonna again make this like rocket shape of like 0, 0, 1, 1, 4, 2, and then 9, 3, which if this is 4, 5, 6, 7, 8, 9. Voila. So even if you flip back to like 1.3 lesson, I think we wrote the anchor points for each of the like parent functions. We wrote it for like the absolute value, the square root, and the reciprocal. So you could even just memorize those points to have it. I don't need to see any sort of like mathematical calculation for how you got these anchor points. I would just assume you know where to plot it. But okay, you've got these points. Now you need to go through these transformations and say like, what's your A? What's your K? What's your D? What's your C? And create a mapping rule from that. And then I would say plug in these first 3 points. Just do the first 3 points of the square root function to find it. Okay, we got 4 minutes to the bell, so let me just do this super quick. So we said for our transformations, we've got a vertical stretch by a factor of 3, and it's reflected in the x-axis. So that is also related to A. So those 2 things are going to make A. So A is -3. It doesn't tell me anything about K. So K is just 1. And then it tells me that I'm shifting 5 units to the right, friends, in case this is confusing. So 5 units to the right means we're going to use +5. And then C, if we are not shifting up or down, C is just 0. We only use a placeholder for 1 if it's A or K. And then we're going to take our mapping rule. And our mapping rule is going to be X over K plus D, A, Y plus C, which if you want to simplify this to just X plus 5 and -3Y, you can. And you're going to take your points and you're going to send them through the mapping rule. So we've got 0 plus 5, -3 times 0. That's just going to give me 5, -3. 1, 1 through the mapping rule. Ah. It's like a race for the clock for lunch. 6, this is 0. I just noticed that now when I did that one. And then we said 4, 2. So 9, -6. So when you go to plot this, friends, 1, 2, 3, 4, 5, 6, -3, and then 9, -6. 1, 2, 3, 4, 5. Voila! That is your shape. And this is just saying transformation notation. I lost people. Yes, sir. Notation. And the mapping rule. This is all for video purposes. People say hi. Say hi, YouTube.
Hi, YouTube.
There you go. Peace out.